Hello everyone, and a very warm welcome. Welcome to our video on the top Kubernetes interview questions you must know. I know that stepping into the world of Kubernetes can feel like learning a whole new language, and preparing for interviews in this space can seem daunting. It's a powerful platform, no doubt, but with that power comes a learning curve. My goal here isn't just to list questions and answers, it's to help you understand the why behind them, to build that foundational knowledge that truly makes a difference when you're sitting across from an interviewer, or even when you're just trying to get things working on your own. Think of this as your friendly guide through some of the trickier concepts and common sticking points. Whether you're preparing for a job interview or just want to brush up on your Kubernetes knowledge, we've got you covered. We're going to break things down piece by piece, much like how Kubernetes itself orchestrates containers. We'll explore the core ideas, the practical commands, and the troubleshooting techniques that will not only help you answer questions confidently, but also make you a more effective engineer when working with Kubernetes in the real world. So, grab a cup of chai or coffee, get comfortable, and let's dive deep into the world of Kubernetes. We'll tackle these questions one by one, ensuring you walk away with clarity and confidence. I remember when I was first getting started, having someone to explain the fundamentals in a clear way was invaluable. That's what I aim to do for you today. We're in this together, and by the end of this video, you'll feel much more prepared to showcase your Kubernetes skills. Let's get started. So, one of the first things you'll often be asked, or even just need to know for your own development, is how to run Kubernetes locally. It might seem like a big, complex system designed for massive data centers, and it is, but you can absolutely get a taste of it, and a very functional one at that, right on your own laptop. The key here is understanding that local setups are designed to simulate the real thing, giving you a playground to experiment, learn, and test your applications before they ever see a production environment. Tools like Minikube are incredibly popular because they spin up a single-node Kubernetes cluster inside a virtual machine on your computer. It's a fantastic way to get your hands dirty without needing a multi-server setup. Think of it as your personal compact Kubernetes lab. Beyond Minikube, you've got other excellent options. Kind, which stands for Kubernetes in Docker, is another great choice, especially if you're already comfortable with Docker. It runs Kubernetes cluster nodes as Docker containers, making it lightweight and fast to start up and tear down. Then there's Docker Desktop. Many of you might already have it installed. It now comes with an option to enable a Kubernetes cluster with just a click, seamlessly integrating it into your Docker workflow. Each of these tools, Minikube, Kind, Docker Desktop, fundamentally aims to provide you with that essential local cluster experience. This isn't just about answering an interview question. It's about empowering your development process, allowing you to iterate quickly and build robust cloud-native applications from the ground up. Alright, let's talk about Kubernetes load balancing. When your application starts to get traffic, you can't just have all of it hitting a single pod, right? That pod would get overwhelmed and your users would have a bad time. Kubernetes load balancing is all about intelligently distributing that incoming network traffic across multiple instances of your application, which are your pods or containers running within the cluster. The core idea is to ensure high availability and reliability, making sure no single pod becomes a bottleneck and that your application can handle fluctuating loads gracefully. It's like having a smart traffic controller for your services, directing requests to where they can be best handled. Now, how does Kubernetes actually achieve this? It uses a concept called services. You'll encounter different types of services, each with its own way of managing traffic, is the default and exposes the service on an internal IP within the cluster, good for inter-service communication, exposes the service on each node's IP at a static port, allowing external access if you know the node IP and port. Then there's, which is typically used with cloud providers. It provisions an external load balancer that routes traffic to your service. And finally, is more sophisticated, providing HTTP, HTTPS routing, SSL termination, and name-based virtual hosting. It's not a service type itself, but acts as an entry point, managing external access to services, usually HTTP. Understanding these options is key to designing well-architected applications on Kubernetes. Often in an interview, you might be shown a snippet of a YAML configuration file and asked to explain it. Let's look at a common scenario. Injecting sensitive data into your pods using environment variables sourced from Kubernetes secrets. Imagine you see a section in a deployment manifest under a container's definition. It might have an entry where is, and it points to a. This will then specify the of a Kubernetes secret, say, and a within that secret, like. This setup is incredibly important for security and good practice in application configuration. What this configuration is telling Kubernetes is this: for this container, create an environment variable named. The value for this variable shouldn't be hard-coded here in the deployment file. Instead, go find a Kubernetes secret object named. Within that secret, look for a data entry with the key and use the value associated with that key as the value for my environment variable. This mechanism is crucial because it separates your sensitive configuration, like database passwords, API keys, or tokens, from your application's deployment definition. Secrets are stored securely by Kubernetes and are only made available to the pods that are explicitly granted access, ensuring your application can access what it needs without exposing sensitive information in your version-controlled manifests. Chapter 4. Troubleshooting unscheduled pods when your pods won't start. One of the most common operational challenges you'll face, and a frequent interview topic, is troubleshooting a pod that's stuck in a pending state, meaning it's not getting scheduled onto a node. The heart of this process in Kubernetes is the scheduler. Its entire job is to look at newly created pods and decide which node is the best fit for them to run on. If the scheduler can't find a suitable node, your pod remains unscheduled. There are a multitude of reasons why this might happen. Perhaps the most frequent culprit is resource exhaustion. Your nodes might not have enough available CPU or memory to meet the pod's requests. Or maybe there are specific node selectors, taints, or tolerations that are preventing a match. So, how do you figure out what's going wrong? Your primary tool here is, the command is your best friend. Run this, and scroll down to the events section. This will often give you a very clear message from the scheduler explaining why it couldn't place the pod. Things like 0 out of 3 nodes are available, 3 insufficient CPU. Another invaluable command is, this shows you a stream of all recent events in that namespace, which can provide broader context or reveal other related issues. Carefully examining these events is the first and most critical step in diagnosing why your pod is playing hard to get. Chapter 5. Pinpointing pods, assigning pods to specific nodes. Sometimes you need more control over where your pods land. Perhaps you have nodes with specialized hardware like GPUs, or maybe you want to co-locate certain pods for performance reasons. So the question arises, how do you run a pod on a particular node or a specific set of nodes? Kubernetes offers several mechanisms to achieve this, each with its own nuances. The simplest, though often not recommended for its rigidity, is you can directly specify the of a node in your pod specification. If that node exists and is available, the scheduler will assign the pod there. However, if the node is down or doesn't exist, the pod won't run. For more flexible and robust control, we look towards and is fairly straightforward. You label your nodes, for example, or, and then in your pod spec, you add a field that specifies these key value pairs. The pod will only be scheduled on nodes that have all the matching labels, is a more expressive and powerful successor to. It offers hard requirements, which must be met for a pod to be scheduled, and soft preferences, where the scheduler will try to satisfy the condition, but will still schedule the pod if it can't. Node affinity rules are based on node labels, giving you fine-grained control over pod placement strategies. Chapter 6. Exposing your services, making them externally accessible. Let's say you have a service defined in your Kubernetes cluster, perhaps a service that's only accessible internally. Now you need to expose this service to the outside world. How do you transform an internal service into an external one? The most common way to do this, especially when working with cloud providers, is to change the service to. When you set in your service manifest, Kubernetes will typically interact with your cloud provider's infrastructure, like AWS, GCP, or Azure, to provision an external load balancer. This external load balancer gets its own public IP address and will route external traffic to your service, which then distributes it to your pods. When you define a service of, Kubernetes also automatically creates a for it as well. You can explicitly define this in your service YAML if you need a specific port, for example, alongside. And so the provided YAML spec does exactly this. It tells Kubernetes, I want this service to be externally accessible via a cloud load balancer. Internally, it listens on port 8080 UDP and forwards to pods on port 8080. Also, expose this service on port 32412 on each node. This makes your application reachable from outside the Kubernetes cluster, which is essential for most user-facing applications. Deploying changes in Kubernetes, especially in a production environment, can be nerve-wracking. A small typo in a manifest file could potentially cause downtime or unexpected behavior. So, a crucial question is, how can you test a manifest to see what Kubernetes would do without actually applying the changes and potentially breaking something? The answer lies in the flag available with. This is an incredibly useful feature that allows you to validate your manifest files and preview the outcome of an operation before it's committed to the cluster. It's like having a dress rehearsal for your deployments. When you use a command like, you're telling to go through all the motions of processing your manifest, checking its syntax, validating its structure against the Kubernetes API schema. But to stop short of actually sending it to the API server to create or modify resources, the part means the validation happens on the client side. There's also which sends it to the API server for validation and admission controller checks without persisting the object. Using is a quick way to catch many common errors and understand the potential impact of your changes, giving you peace of mind before hitting that final apply button. It's a simple habit that can save you a lot of trouble down the line. We all make mistakes, or sometimes a new version of an application introduces an unexpected bug. In such scenarios, you need a quick and reliable way to revert to a previous stable state. So, how do you initiate a rollback for an application in Kubernetes? Thankfully, Kubernetes, through, provides a built-in mechanism for this, primarily for resources like deployments, stateful sets, and daemon sets, which manage rolling updates. This feature allows you to undo a recent deployment and revert your application to a previously deployed revision, minimizing downtime and impact on your users. It's a critical safety net for your CI/CD pipelines and manual deployments alike. The command you'll most commonly use is, when you execute this, Kubernetes will revert the specified deployment to its previous revision. By default, it rolls back to the immediately preceding version. You can also roll back to a specific revision if you know its number by using the flag. Before you undo, it's often a good idea to check the history of your deployments using. This will show you the different revisions that have been deployed, allowing you to make an informed decision about which version to roll back to. This capability is fundamental to maintaining stable and reliable services. As your Kubernetes applications grow in complexity, managing all those individual YAML files for deployments, services, config maps, and secrets can become quite cumbersome. This brings us to an important question. How do you package Kubernetes applications effectively? The most widely adopted solution in the Kubernetes ecosystem for this is Helm. Helm acts as a package manager for Kubernetes, much like or for Linux systems or for Node.js. It allows you to define, install, and upgrade even the most complex Kubernetes applications using a packaging format called charts. A Helm chart is essentially a collection of files that describe a related set of Kubernetes resources. These charts use templates, which means you can parameterize your Kubernetes manifests. Instead of hard-coding values, you can define them in a separate file or provide them at installation time. This makes your application deployments reusable, configurable, and shareable. For example, you can have one chart for your web application and deploy it to development, staging, and production environments simply by using different configuration values. Helm greatly simplifies the management of application lifecycles on Kubernetes, from initial deployment to upgrades and rollbacks, making it an indispensable tool for many teams. We've touched on before, but it's often discussed alongside another concept and its counterpart. So, what's the difference between node affinity and pod affinity, and why would you use them? Node affinity, as we know, is all about influencing where a pod gets scheduled based on the properties of the nodes themselves. Things like node labels indicating specific hardware, geographic location, or maintenance status. It helps you ensure your pod runs on a node that meets certain criteria. For example, a node with a GPU for a machine learning workload. It dictates the relationship between a pod and the characteristics of potential host nodes. Pod affinity, on the other hand, concerns itself with the relationship. It allows you to specify rules that influence how pods are scheduled relative to other pods already running in the cluster. For instance, you might want your web front-end pod to be co-located on the same node or in the same availability zone as your back-end cache pod to minimize latency. This is where pod affinity comes in. Conversely, lets you ensure that certain pods are scheduled on the same node, perhaps for high availability reasons. For example, you don't want all replicas of your database on the same physical machine. Both node affinity and pod affinity/anti-affinity provide powerful declarative ways to control pod scheduling, leading to more optimized, resilient, and efficient application deployments. And there we have it, a tour through some of the top Kubernetes interview questions. Thanks for watching. We hope these questions help you ace your next Kubernetes interview. Remember, the goal isn't just to memorize answers, but to truly understand the underlying concepts. Kubernetes is a vast and evolving ecosystem, and continuous learning is key. These questions cover fundamental areas, but the real skill comes from hands-on practice and digging deeper into how these components work together to create such a powerful platform for orchestrating applications. I encourage you to take these concepts and experiment with them. Set up a local cluster, deploy some applications, break things, and then fix them. That's often the best way to solidify your understanding. The journey of mastering Kubernetes is ongoing, and every problem you solve, every concept you grasp, makes you a more proficient engineer. The community around Kubernetes is also incredibly supportive, so don't hesitate to explore forums, read blogs, and contribute where you can. Keep building, keep learning, and you'll be well on your way. If you found this video helpful and want to continue learning with us, please show your support. Don't forget to like, share, and subscribe for more tech content. Your engagement helps us create more content like this, designed to help you navigate the complexities of modern technology. We're excited to be a part of your learning journey. All the best with your interviews and your adventures in the world of Kubernetes. Until next time, take care.